So let's try to make this thing, to see how this thing is working. Now I'm in the RF position, and let me first zero, let me go back with the camera, and zero the meter. It's already zeroed, okay, and then go, let's say, to a frequency, and we have now 8 volts peak to peak at that frequency. And I can actually use my oscilloscope here. Let me switch off the lights a little bit so you can see it a little bit better. I can switch off I can check this voltage with the oscilloscope, and I'm gonna put the probe here, okay, and check the voltage. Let me put the probe in there, okay, and we're now at 2 volts per division in this oscilloscope. So we're a perfect match of, we have a perfect match of 8 volts peak to peak. Now notice that with this T connector there, I also have a load connected to it. This is a 50 ohm load, so I'm really loading down this port now with 50 ohms. But even if I load it down, let me remove this connector and load the port down with 75 ohms, just a little bit, right, so, and let me check again the voltage here, and now at 75 ohms we are again at 8 volts peak to peak. And let's make it extreme and leave this port open completely. So no loading here, here's just the oscillator impedance. And let me check again. And again we have 8 volts peak to peak, just like it is read on the meter. So that's the advantage of my modification here. I'm actually using external loading resistors here, and present an output impedance of whatever impedance I want, okay? It doesn't matter if I load it down to 75 ohms or 300 ohms, or just leave it completely open. It's just going to work, because the ALC is trying to keep up with any voltage drop in the oscillator and brings back the voltage to the appropriate level. So previously previously I have used a 50 ohms load and 75 ohms, and the same peak-to-peak voltage was appearing at the output of the generator, no matter the load that I used. So I presented an output impedance for the generator of different values, 50 ohms, 75 ohms, or whatever, but the voltage peak-to-peak was staying the same. The output voltage was staying the same. And if I put a through-hole attenuator at the output port of the generator of 6 decibels, then I will be able to read the middle scale in the voltmeter. And if I put a 12 dBs attenuator, I then will read the bottom scale. So by using 2 external attenuators in the RF generator, I will have the ability to reach down to 0.1 volts and maybe 0.05 volts of output voltage, and still be able to correctly read the scales here in the meter without needing any change in these scales. Now let's test a bit the voltmeter. We are at let's put this to 5 volts peak to peak. Okay, we are in the RF position now, or generator position, and let's zero the meter. It's already zeroed, and we have put 5 volts peak to peak. Okay, and now we switch to the RF to the voltmeter position, and notice that I have zeroed here with using this this potentiometer, this trimmer here, I have zeroed the meter here exactly at 5 volts peak to peak. And the reason I did so was because when I use my positive probe here, it should go, the values of the voltage should go negative now, okay? This outputs a positive voltage, which is read by a counterclockwise deflection of the needle of the meter. So I should read now directly 0 volts if the voltmeter is working correctly. And here we go. I am touching here, and see I'm reading 0 volts. Disconnect it. Read 0 volts. Okay. Disconnect it. Read 0 volts. So it's working correctly. This solution works correctly. But I only need a negative probe in order to be able to zero the meter here exactly at the 0 point of the meter. And when I read 5 volts, minus 5 volts actually, from the probe, the deflection of the meter will go to this position, to the 5 volts peak to peak. So yeah, that was a really long video, and many things have said, and I was talking a little bit too much, I would say, but I think I explained everything I did with this generator to make it usable in the modern days and make it even better. You know, we can now use our generator here, which has a constant amplitude, and pass this output to a filter, for example. And we can use we can feed the signal through the filter and back to the detector probe, and we can actually track filters here. We can see the response of the filters by reading at the values of in the meter here, in the voltmeter, and draw diagrams and see the actual response of the filters. Or just use these to pick filters. So we have converted an instrument which was really a usable piece, I would say, due to this impedance change in the output port. We have converted it into something really useful, not only as a constant amplitude generator with well-defined output impedance, no matter of the attenuator, but also to a separate vacuum tube voltmeter detector, RF voltmeter, which will be able to detect standalone the signals from other sources, or use it in combination with the internal signal generator of this instrument, and track different filters and do all sorts of interesting things with this instrument. So yeah, that was it. Thank you very much for watching. I hope you enjoyed that video, and thanks for watching.